Welcome everyone for this next lecture. So in this lecture we will be discussing common bus system using multiplexer. So there are two ways in which we can design this common bus system. So one is through multiplexer and other one is through tri-state buffer. So in the next lecture we will see the bus system using tri-state buffer. So this is going to be the content. We'll start with the multiplexer and then we'll see how we can create multiplexer how we can create common bus system using these multiplexers. So first of all, what is a multiplexer? So it is a combinational circuit that receives binary information from one of 2 raised to the power n input lines, and these inputs, one of these input will be directed to a single output line. So it is something 2 raised to the power n cross 1 multiplexer. Now, which of these 2 raised to the power n input line would be selected? That depends on the selection line, or we call it selection input also, right? So it will have, we'll call it 2 raised to the power n cross 1 multiplexer, right? Where n is the number of select line. So we may have 2 cross 1 multiplexer, we may have 4 cross 1 multiplexer, 8 cross 1 multiplexer, and so on, right? Everything will be in the power of 2. 2 raised to the power n input data line, and it will be directed to one output, single output will be there, and total number of selection line will be n, right? So this is one of the example of 4 cross 1 multiplexer. So here you can see, like, we are having a multiplexer of 4 cross 1. Okay, so if we see, 4 is basically 2 raised to the power 2, right? So here we are getting 2 select lines. So these are the 2 select line S1, S0, and 4 input line will be there. So what happens? And single output will be there. Let us call it Y. What will happen? As we know, if we have 2 select lines, so there may be 4 combinations. It will be 0, 0, 0, 1, 1, 0, and 1, 1. So when select line values are 0, 0, so on the output line we'll get first, we'll get the value from the first input line. So it is a kind of selection we are doing. So when it S1, S0 is 0, 0, so we are selecting first input. First, we are selecting the data from the first input line, and that data will be visible on the output line. Similarly, when it is 0, 1, data from the second input line will be visible on the Y, that is output, and so on. What multiplexer is doing, it is also known as data selector. So it is doing a kind of selection of one of the input and redirecting it towards the output line. Now, if we see the internal implementation of the multiplexer, so we can design it like this. So here we are having these select lines, and here we are having these 4 inputs. So these 4 inputs may be anything. Again, like I0 may be 0, it may be 1. Again, it may be 0 or 1, whatever it is. Like suppose 0, it may be. Let's suppose this is also 0. So what will happen? Now this Y will get one value out of these 4 values, 4 input values, right? Now suppose S0, S1, or you can call it S1, S0. Now suppose this is S1, S0 is, let's suppose 0, 1. So what happens at 0, 1, as we have seen in the previous slide, we have seen a truth table. So when it is S1, S0 is, this is S1 and this is S0, right? When this S1, S0 is 0, 1, so I1 will be selected, right? So this will go on the output line, that is Y. So here you can see Y will be 1. when S1 S note is 0 1. Similarly, when S1 S note is let's suppose 1 1, so this fourth input will be selected, right? What it is doing, it is selecting one of the input and redirecting it on the output on the basis of these values of S note and S1. Now, what we can do when we talk of common bus, so common bus is something where multiple uh, devices or multiple registers are connected with a common bus, and one of the register will use this bus. So we can do this with the help of multiplexers, right? So a bus structure consists of set of common line that we are calling as bus, common bus, and one for each bit of register, right? So I have already told you there are two ways. So one is multiplexer and other one is tri-state buffer. So this is the example of a common bus having four registers, and the size of each register is 4 bits. So you can see here we are having four register A, register B. Every register is having 4 bits, register C and register D, right? And what we are doing, we are using four multiplexers here. So what is happening, and the size of each multiplexer is also 4 cross 1. So incidentally, this example is having 4 register, and each register is having a size of 4 bits. But it may be something like you are having 4 register and the size of each register may be 8 bits, right? So it may be anything. So we'll see how we decide how many multiplexer we'll be using and what is the size of each multiplexer. So here you can see 1 bit from every register is connected to one multiplexer, right? So if I see this first multiplexer, so it is getting 4 input values, and it is getting 4 input values from all the registers. So 1 bit from all the registers. Similarly, this one also getting 4 bits from 4 different registers and so on. So we can see here, if I say, first of all, what is the size of multiplexer, or let's see how many multiplexer we'll be using. So you can see here, every multiplexer is giving me 1 bit, right? 1 bit from register. So I can say how many multiplexer I'll be using. So it will be equals to the size of the register, right? So as we can see here, we are having 4 bits, and these 4 bits, suppose I want on the common bus, I want that data of register A to be transferred with the help of common bus. So one multiplexer is giving me 1 bit. So how many multiplexer I'll be using, that will depend on the size of the register. That is one thing. Then what is the that is the number of multiplexer, right? Is equals to the size of register, right? Then size of multiplexer. What is the size of multiplexer? So you can see here, on its input, multiplexer is getting 1 bit from every register. So as we can see here, we are having 4 registers, so it is getting 4 bits. If we are having, let's suppose, 8 register, so this multiplexer will be getting 8 inputs, right? So size of multiplexer will depend on the total number of registers we are having, right? Now, which bit is going to be selected, that will depend on the value of the select line, that is S1 and S0. So if this S1 and S0 is, let's suppose, 0 0. So here I can see register A will be selected. So how register A will be selected? So when it is 0 0, first input line of every multiplexer will be enabled. Will the first input line data will get on the output. So at the first input line of every multiplexer, we are getting the data from register A. Here we are getting A1, first one we are getting A0, then A2, then A3, right? So when this is 0 0, first input line will be selected. So we'll get all the bits of register A on this common bus. So register A is selected. Similarly for 0 1, B is selected, 1 0, C is selected, and 1 1, D is selected, right? So which registers data will be available on this common bus, that will depend on the value of this S1 and S0. So this is what I have told you. Number of multiplexer required will be equals to number of bits in each register, and size of multiplexer is equals to the total number of registers we are having in the system. This I have already told you. We are having registers having values number from 0 to 3. Then there is a bus consisting of 4 cross 1 multiplexer. Why we are having 4 cross 1? Because we are having total 4 registers, right? And then on the basis of select line, a particular line of the each multiplexer will be enabled, and data of that or data of a particular register will get on the output, right? So this is what is written. Two selection lines are connected, and these value of these selection line will actually decide which register's data is available on the output screen. So if it is 0 0, so we'll get the content of register A. If it is 0 1, content of register B, right? Like here you can see if it is 0 1, then content of register B will be selected. Okay. So we can generalize it if we are having, let's suppose we are having a problem. So how we'll decide? So if we are having k registers and each register size is n bits. Okay. So first of all, total number of register will decide the size of the multiplexer. So if we are having k registers, then size of the multiplexer is going to be k cross 1. And total number of bits will actually decide the total number of multiplexers, right? So if we are having n number of bits, so total number of multiplexers needed to construct the bus is equals to n. This is the main thing that we need to remember, right? So in the next lecture, we'll see one numerical problem on this, right? So thank you.